Everyone. So today we're going to start a very complex topic called recursion. So what is recursion? Well, recursion is basically a way of taking a problem and splitting it up into smaller parts. So this is a very interesting GIF of the Mandelbrot set, which is a recursive function. It's based on a recursive function. And if you can see here, as you zoom in, right, things get more and more complex because the thing is, all of these little squiggles are children of parents and they have children and they have children, right? So you keep on splitting it into smaller and smaller and smaller parts. um, yeah, it's a bit psychedelic, but it's very interesting. It's a very good example of the Mandelbrot of what recursion is. So again, the definition is you take an initial problem and you break it down into its smaller parts. The key about recursive function architecture, which is what we're going to go over next, is that the function will call itself. Basically, here's an example. There are two parts to a function that's recursive. The first is a base case, right? And this is some pseudocode just telling you how a recursive function is defined. So if the base case is met, right, then we return. We have to have a base case because if not, we're going to infinitely call this recursive function and eventually run into an error. So we have to stop this function from repeatedly calling itself. So the thing is, when it does call itself, it's going to first check if a condition is met. If it is met, it'll return, it'll go out of the function. If not, then you're going to call your function again, call yourself again, and then continue this process, right? Until this base case condition is true, and then you break out and you return, right? So that's kind of the basic architecture of a recursive function. So here's an example of recursive function. This is a simple recursive elimination that basically takes in a number, right? And it'll subtract 1 from that number until our number is 0. So basically what we're going to do is we first put our base case, right? If our base case is met, so if our number is 0, we return. But if not, right, then we print out our number and we subtract 1 from that number and we call our number again. Does that make sense? So this is what we're doing. We're if it's not met, if it is met, if it's 0, we break out. That's our end condition. Our terminal condition is our base case. If not, then we print the number, we subtract 1 from the number, and then we call ourselves again. So when we call ourselves again, we kind of jump up here to our initial function. Again, check the base case, print, subtract, call again. We check base case, print, subtract, call again, right? So that's kind of the process. It's almost like a for loop, but it's slightly different because in a for loop, you're iterating over a set number, and then once the number is once our condition or our terminal number is met, then we break out. But here we have to include this base case in order to break out of our recursive function. If we don't, then we're just going to have an infinite recursive function that never stops. So instead of stopping at 0, it'll just go on until negative infinity, right? And then here, so this is the output, right? 10, 9, 8, 7, 6, 5, etc., right? So yeah, this is a very simple recursive function. Yeah, again, this is like a for loop. Every for loop can be written recursively. That's a nice way of thinking about it. Yeah, so here's another example of a recursive function. So in this case, the goal of this function is basically to remove the last 5 elements of a list, right? And if the list has less than 5 elements, we're just gonna remove every element in that list, right? So what we want to do is, again, we want to check the base case because we want to make sure our list is long enough to remove 5 elements, right? If we get to the point, so if we remove, right, and then we get to the point where our list is 0, has 0 elements, we'll run into an error if we try to remove again. So we have to check this case. We have to check if the length of a list is 0, or num tracker. So num tracker is basically, it's going to keep track of how many things we've removed. So if and we'll basically iterate it down or we'll subtract one from it every time we call the function to keep track of how many things that we've removed, right? Or how many things are, you can think about it as being more like how many things are left to remove, right? So if we have 0 things left to remove, that means we're done. So we can break out. So if this is true, we'll break out. Or, right, if this is true, so if our list has 0 elements, we can't remove anymore, then we have to return. Now here, this is a way of removing the last element. We can use the pop function for lists. So we're going to pop the last element. So we call the last element by just referencing the last index, which is always 1 minus the length of our list. And we're going to print the list. And then here we have to increment the counter. If not, it's going to keep on removing until this condition is met, right? However, our goal is to only eliminate the last 5. So that's why we have to have this other counter that will increment and keep track of how many things are left to remove. And then here again, we call the function inside of our recursive function. So again, here we call ourselves. And then this part over here is just basically calling the function again. So I've named num tracker as being 5, so this is 5. My list is this list, so my list is over this list, and then we print the list. So you see, we start off with 1, 2, 3, 4, 5, 6. Sorry, this removes not the last 5, but the last 4, because again, it's exclusive. So we're gonna basically remove 1, 2, 3, 4, 5, or 1, 2, 3, 4 elements, and then be left with this. Yeah. And this is similar, so this kind of a function is similar to how a lot of machine learning algorithms like recursive feature elimination work, in that like you'll eliminate the features recursively to find, it's a way of basically testing your model, finding the weights of the features, and the ones with the lowest weights get eliminated each time from our list. So you can think about it, this sort of framework is the basis of this machine learning method. Yeah, and so next lesson we'll go over recursive backtracking, but I think that's it for now. Leave any questions in the comments below. I'll be sure to answer them. Yeah, thank you so much.